Hello everyone, welcome to Gravity Cloud. This is Bindu and going to explore math with you. Math. Math is everywhere and math is full of addition, subtraction, multiplication, division, numbers and expressions, right? So this math is full of calculations and lot more to explore in it. And in this class, let's have some fun with the math, right? I hope you are ready to have fun with me. So let's look at fun with math. So this is Ritu. And what is Ritu thinking? Ritu is thinking, how can I multiply bigger numbers faster? You all know how to multiply numbers. But how can we multiply them faster? Let's look at it. Okay? So yeah. First, multiplication of bigger even numbers by 5. So how to multiply with 5 easily, right? Before moving into this, you all know multiplication by 10 is very simple. Suppose I have 35. If I multiply it with 10, it's just 350, right? You just put a 0. Suppose 1, 5, 4, 3, 9, 6. We have some number and you're multiplying with 10. That means you'll just put 0 at the end. 1, 5, 4, 3, 9, 6, 0. Isn't it simple? Yes. Even multiplication of 5 is also as simple as it. Let's look how. So, how is it so simple? It's so simple for even numbers and how? The thing is, you divide the full number with 2 first and then multiply by 10. How? So the number we have here, before moving into bigger number, let's look at a smaller number. So 234 into 5. So I want to do 234 into 5. This is an even number. First, let's find the division of 2 here. So 234 by 2. So 2 becomes 1, 3, so it becomes 1. And 1 gone, 14. So this is 7. 117 and just put 0. Just put 0. So the answer is 1170. Right. Isn't it interesting? Do for one more number now. 256 into 5. Again, how will we do this? So 1, 4. So you'll go with 2 and 16 is 8. 1280. That's it. Am I clear? So multiplication with 5 means the number is divided with 2 and just 0 is kept at the end in one's place. So let's do this for a bigger number just in 5 seconds. So without wasting time, let's start. We'll multiply with 5 in 5 seconds. So start. So for 2 it becomes 1, 1, 2, 2, 0 comes as it is, 6 becomes 3, 5. So you are dividing with 2 and 1 gone, 18 is 9, right? So for 4 on division with 2 becomes 2, 3, 3, 8 becomes 4, 1, 4 becomes 2, 0 as it is and 6 comes as 3. And now we are just putting 0. So, on multiplying this, we get 11220, 3292, 33412030. Such a big number with 5 seconds multiplication. So, we'll do few more sums of this kind in this session. So, let's look into one more question now. Multiplication of bigger even number by 5. So these are the two numbers. Let's solve them now. Right. So the number is 29306. Right. 29306. Stopwatch on for 5 seconds. So let's divide with 2 first. 1, 4, 6, 5, 3. Right. How did I do it so fast? Let's do that also. So how did I do so fast? 29306. 2 divided by 2 is 1. Clear. Now 9, I cannot divide 9, I can divide 8. So 8 by 2 is 4. So 1 comes here. 13, right? 13 is not possible, but I can divide 12. So 6. And again 1 is gone. So 10, 5. And 6 is 3. So 1, 4, 6, 5, 3, right? So the answer for this number multiplication is 1, 4, 6, 5, 3. Am I done? No, we need to put 0. 1, 4, 6, 5, 3, 0. Right? Let's solve the next bit now. So 5, 4, 5, 9, 8, 6 into 5. So again, first divide it with 2. On division 5 by 2, we get 2. So 1 carried. 1, 4, 14. So 7. 5 again. So 2 2 is 4 and 1 carried. 19. 19 cannot be divided by 2. So we'll divide 18 and write 9. And again 18. So 9. 3. And now since we are multiplying with 5, so after dividing with 2, we need to put 0. That is, we are multiplying with 10. So the answer is 27,299,30. Clear? So I hope you enjoyed how to multiply numbers by 5, even numbers by 5. Even this process can be done for odd numbers, but there on dividing with 2, we will get decimal first. Okay? So there it may not be so useful, but for long even numbers, this is very easy trick. Now, let's look how to multiply by 11. How to multiply bigger numbers by 11. Okay. First, let's do for 2-digit numbers. Multiplication of 2-digit numbers by 11. So, 29 into 11. So, when you are multiplying by 11, what exactly happens? So, normal multiplication shows 29 into 11. So, 9 into 1, 9 into 2. Again 9 into 1, 9 into 2. So 9, 11, 3, 3, 1, 9. The same technique is used without writing all this. How? Whatever the digit is. Now the digit is 29. So whatever the digit in ones place comes in the ones place first. Now in the tens place, what will come? So we get 2 plus 9. What is 2 plus 9? 2 plus 9 is 11. So 1 and 1 is carried. Then tens place into 11. That is 2. So 2 plus 1, 3. Right? So let us do for one more number. 54 into 11. So this is going to be a 3-digit number where first place is 4. Ones place is always the ones place of the digit. 4 as it is. Coming to the tens place, 5 plus 4, which is 9. And then hundreds place is the number 5. So 594. Let's solve for one more number. So let us take 66 into 11. How to solve this? Again, 3 digits. So ones digit is always the ones digit. 6. Coming to the next place. 6 plus 6, 12. We cannot write 12. So 2 and 1 is carried up. And the hundreds place actually is 6. But we have plus 1. So we'll write 7. 726. Clear? So multiplication of 11 is with, for 2-digit numbers, we get 3 digits as the solution. And ones place is the ones place as it is. Right? Let's solve few more questions. 47 into 11. 47 into 11 is again a 3-digit number. 1, 2, 3. How will we do this? The ones place is 7. So ones place is fixed as 7. What is in tens place? 4 plus 7. What is 4 plus 7? 11. So 1 comes, 1 is carried. And what is in tens place actually? 4. So plus 4. 1 plus 4 is 5. So 517 is the solution. Clear? One more question. 63 into 11. 3-digit number. So ones place is 3. So the ones place should be 3. What about the tens place? 6 plus 3 is 9. So 9 in the tens place. And what is the hundreds place? The tens place of the digit is 6. So 6 into 1 is 6. So 693 is the answer. So I hope you understood how to multiply 2-digit numbers with 11 easily. Now let's look at how to multiply 3-digit numbers with 11. Multiplication of 3-digit numbers. This also follows the similar pattern as 2-digit numbers. Let's see. We have 294. Now on multiplication we get 4-digit numbers. Clear? And what are these 4-digit numbers going to be? We'll see now. Always the ones place will be the ones place of the number. This is fixed for 11. So this is going to be 4. No change in this. Now tens place is again the same pattern is followed. 9 plus 4. And what is 9 plus 4? 13. So 3 here, 1 carried. Next, hundreds place is 2 plus 9. 2 plus 9 is 11 and we already have 1. So this becomes 12. So 2 here and 1 here. Right. And then coming to the thousands place 2. What is the last digit? 2. And we already have 1. So 2 plus 1, 3. So the solution is 3, 2, 3, 4. Clear? This is how you will multiply for 3-digit numbers also. So to get more clarity, let's solve one more question. You see, I did not do any calculation, but I got the answer easily. Right? Now let's do for the 693 into 11. 693 into 11. Again we get 4 digits. First digit is going to be the ones place. So it is 3. Now, what is tens place? Good, you might have guessed already. It is 9 plus 3, 12. So 2 here and 1 carried. Then, what is the hundreds place? 6 plus 9. 6 plus 9 is 15 and I already have 1. So this is going to be 16. So 6 and 1. Now, the thousands place is the 6 plus 1, 7. So 7, 6, 2, 3. Looking at how to multiply 2-digit numbers and how to multiply 3-digit numbers, I hope you got the pattern to how to multiply big numbers, even 10-digit numbers by 11. It's the same pattern that we follow. Right? Now it's a task for you. Try to multiply 6, 7, 5, 4, 3, 2 by 11. Guess the pattern and try to multiply it with 11. And we can interact about it in our weekend session. So let's move to the next question now. Next, we will explore 3-digit numbers by 11 some more. Okay? So these are also your practice questions. So 524 into 11. I'll do one for you and one more for you as a homework. So 524 as 11 as we have done till now. How many digits will we get? 4 digits. So 1, 2, 3, 4. And what is the ones place going to be? The ones place of the number, that is 4. So 4. And what is the tens place going to be? Sum of the digits 2 and 4, 6. What about the hundreds place? It's sum of 5 and 2, 7. And then what about the thousands place? It is just the biggest number 5. I mean the number in hundreds place, which is 5. Clear? So 5, 7, 6, 4. Try to solve 105 into 11 as your homework. Okay? Yeah. 29 into 21. So how will we multiply such numbers? So multiplying by 11 and multiplying by 5 are done. Now we have random numbers and how are we going to multiply them easily? Let's look into that now. So here we have 29 and 21 and it's quite easy. So 9 into 1. Let's look at ones places first. 9 into 1. That is 9. So 0, 9. We'll put it as 0, 9. And we have 2 and 2. Whatever number you have, add 1 to it. So 3. 3 into 2 is 6. So this is going to be 6 not 9. Clear? Let's look at one more example. 63 into 67. What are the ones places here? The ones places are 3 and 7. And multiply 3 and 7. We get 7 3s 21. So 7 3s 21. And then 6 and 6. Instead of 6, we'll add 1 and it becomes 7. And then what are we doing? We are multiplying 6 and 7. 6 7s 42. So the answer is 4221. Clear? This is 4221. And this is how we do. Just have a look at it once. Let's solve few more problems of this kind now. Find the product of 69 into 61. Again, 9 into 1 is 9 and we have 0, 9. Always remember, if it is a single digit number we get in product, we put 0 also. So this is going to be 0, 9, right? And what about 6 and 6? As I already told, when you have 6, take 7. 6 7s 42. So 4209 is the multiplication product. Clear? One more question. 7 into 3, 21. 7, so you have to take it as 8. 7 into 8 is 56. So 5621 is the multiplication product. Without doing all the calculations, I am getting the answer so easily. Let us solve one more question. 42 into 48. What is going to be the solution of this number? One's digits are 2 and 8 and we know 8 2s is 16. So this is going to be 16. I have 4, so what should we take? 5. Now 5 into 4, 20. So 2016 is the solution. So this is going to be a simple and useful trick for you to solve your math quickly. Let's look into the next slide now. Again, Ritu is here. And what is Ritu's doubt now? Wow, this is very simple. Okay, so she's happy with the methods we have given her. But can I use multiplication for any numbers? This trick which we use now, can it be used for any 2-digit number multiplication? No, this cannot be used for all. There are certain conditions where we can use this. Let's look into those conditions now. Okay, so the first condition is rule 1. Numbers in tens place must be same. If you have observed, all the numbers given are 27 into 23, 61 into 69, 54 into 57. If you see, in all the cases, the tens place digits are same. 6, 6, 5, 5. So that is one of the important condition. This condition is satisfied, then rule 1 is satisfied. And is this enough? No. There is rule 2. And what is rule 2? Sum of digits in units place must be equal to 10. Is that happening? What is the number? 61 into 69. We had this number. So yes, tens place is satisfied. What about the ones place? In ones place we have 1 and 9. And 1 plus 9 is equal to 10. So yes, if this is satisfied, we can use the trick we have already used. Okay, so let's check for what numbers we can use it and for what numbers we should not use this trick. So 54 into 55. So yes or no, can I use the trick we have used till now? Tens place we have same, but what about 4 plus 5? 4 plus 5 is 9. It's not equal to 10. So no, I cannot use the trick in this case. Let's go for the one more number. What about 46 into 44. Well, in 1's place, in 10's place we have 4 and 4. Yes, first rule is satisfied. What about rule 2? 6 plus 4 is 10. So here you can use the trick, and what will we get the solution as? 6 4s are 24. Again you have 4, so 5 into 4. 5 4s 20. So 2024 is the product. Yes, I hope you got the trick and the rule when we can use the trick. Yes, so hoping that you had fun in this. Now I have few more questions to solve. 54 into 56. So first of all check, can we solve here using the trick or not? How will we check? 10's place is same, rule 1 satisfied. What is rule 2? Rule 2 is sum of 1's place should be equal to 10. 4 plus 6, is it equal to 10? Yes, it is equal to 10. So we can use the trick, and on using trick, 4 into 6 is 24. So 24, we have 5 into 5. So this is, we'll make it as 6. 6 into 5, 30. So 3024 is the product. Next question. 10's place are 1. 8 plus 2 is 10. So rule 1, rule 2 satisfied. So we can use the trick here. So 1 plus 1, so 1 into 1 and 18 into 2. So 8 into 2 is 16. And then what should we do? We have 1 into 1. So we'll do 2 into 1, which is 2. So 216 is the solution. And this is how we can use math and play with it. There are several tricks, and these are the tricks that I have given you in this session. Right? Before concluding this session, let's learn few facts on math, that is on geometry. Okay? So yeah, he is John, and John is very happy knowing the tricks, and he wants to explore math more. I hope even you want to explore math more. So I'll conclude this session by saying 2 more facts to you. So the fact 1, what are these? We have circle, triangle, rectangle. We also have square, trapezium, different shapes. Okay? We have different shapes. And the fact of the day is that among all shapes with the same perimeter, what does perimeter mean? Perimeter is the outline, the measure of outline, the length of this outline, or we can also say sum of all the sides. We can also say sum of all sides. So for suppose perimeter is same for all the 3 shapes, then the largest area is by the circle. The largest area is always by the circle. That is what the fact. So if all shapes are of same perimeter, largest area is by the circle. Then what if all are of same area? If all are of same area, then shortest perimeter is to the circle. Its perimeter is shortest. If all are of equal area, then the perimeter of circle is shortest. Right? So these are the 2 facts. You can try these 2 by taking different perimeters and different areas for different shapes. You can try it as an activity at home and come up with different innovative answers that you got in the interactive sessions. Clear? So one last interesting fact on 0. On 0. What is that about 0? 0 is very special to us. Like this is invented by Indians. So 0 has no value if it is on the left. 0 has a value if it is on the right. 0 is very special. It is neither prime nor composite. Several things to it. And there is one more specialty of 0. That is 0 is the only number that cannot be represented using Roman numerals. We represent all the numbers using Roman numerals. Even if it is 100, we write it as C, right? If it is 10, we write it as x. And for all the numbers, even million, trillions, we represent it using Roman numerals. But 0 is the only number that cannot be represented using Roman numerals. Yes, so I hope you enjoyed all these facts, and with this I'll be concluding today's session. Thank you. Stay tuned.
Hello everyone. So now we'll be going into a few practice questions based on gravitation. Okay, so my name is Seshan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So the first question is here. Both centripetal force and gravitational force by Earth act on the moon. Is this statement true? What do you think? Yes or no? Both the forces act on the moon by the Earth. Yes or no? Now everyone? Yes or no? The answer is no. But why? That's because if I take this as Earth, and if there is moon here, no, let's not take that big. Let's say this is Earth, and let's say this is moon. Now Earth exerts or Earth applies only one force on the moon, and which force is that? That is gravitational force. Only one force. Gravitational force. And this gravitational force will act as centripetal force, because remember this, centripetal is not a new force. It's not a new, or you can call it as, or a separate force. No, it is not. Whatever force will be there, that force itself will act as centripetal force. So in this particular case, gravitational force acts as, what acts as? Centripetal force. Simple. So do both of them act? No, only one force is acting. Gravitational force will act, which will act as what? Centripetal force. Simple. Okay, and hence the answer is no. Good. Another question. Why does the Earth not fall into the sun? Very dangerous, right? Why does the Earth not fall into the sun even when the sun attracts Earth through gravitational force? Why is that? So for this I'll give you 1 minute of time. Write down the answer in your book, and then you can compare your answer with mine. So why is that? Why does the Earth not fall into the sun? Yes or no? Because sun is attracting Earth. Always attracts. Twenty seconds more. Five, 4, 3, 2, 1, and the time is up. Now why does this happen? Let me explain. For that, let's compare two cases. Okay. So let's say first Earth is at rest. Just imagine Earth is at rest. A hypothetical scenario. So let's say this is Earth, and let's say this is Sun. And in this case, when the Earth is at rest, its speed is 0. Then when gravitational force will act, what happens? What will the gravitational force do? the gravitational force will pull Earth towards the sun. And then what happens? Then what happens is, in that case, Earth will fall into sun. When Earth is at rest, that can happen, but Earth obviously is not at rest. What is Earth doing? Earth is happily revolving around the sun. Earth is happily revolving around the sun. Case 2. Right? But again, if I take another case, let's say case 3, where there is no sun. There is no sun. But Earth is moving. There is no sun, but Earth is moving. Then in this case, what will happen? Earth will move in a straight line. Yes or no? Because there is no force acting on it. Who will change the velocity? No one. Earth will move in a straight line. Yes? So when the Earth is at rest, there is sun. Earth will fall into sun. Okay. But when there is no sun will mean there is no gravitational force, but Earth is moving. In that case, how will Earth move? Earth will move in a straight line. But when it comes to the actual case, this is the actual case, when Earth has a velocity and there is gravitational force, the actual case, right? Actual scenario. What's happening here? What's happening is Earth revolves around the sun. Earth revolves around the sun. So what is the force doing in this case? In this case, there was no force. Just a minute. In this case, there was no force and it was going in a straight line. But when there is a force, Earth is rotating or revolving around the sun. So this force is responsible, or it is making the Earth go in a circle, revolve around the sun. So why does the Earth not fall into the sun? Because Earth has a velocity. Because Earth is moving with a speed, and the force here can only make the Earth to rotate in a circle, to revolve in a circle. Okay? So you can write the answer as, because the Earth is moving with a speed, the Earth is moving with a speed, the gravitational force by Earth, gravitational force by sun, can only make the Earth, to revolve around it, not follow into it, to revolve around it. Simple. The force is not able to pull it, but the force is only able to make the Earth go in a circle. Simple. Understood? So if you take these three cases, then you look at it, then it is easy to understand. Good. Now next. If gravitational force acts between all the objects, why are we not attracted by the walls in our room? Why do you think? Again, I'll give you 1 minute of time. So please write down the answer and then you can verify your answer with mine. Why are we not attracted by the walls in our room? That's a very simple, straightforward answer to this. There is one simple sentence and that is the answer. Why are we not attracted to the walls in our room? 30 seconds more. Why are we not attracted to the walls in our room? You can compare your answer with mine. Okay, I'll be writing down the answer. So 5, 4, 3, 2, 1, and the time is up. So why are we not attracted by the walls in our room? That's the question. It's very simple. Because the gravitational force by the walls on us will be, or is very, not will, is very small. In fact, almost negligible, almost zero. Now, why can we say, or how can we say it is almost negligible? It's very simple. How can we say it's almost zero? Because the reason behind this is G is equal to 6.67 into 10 power minus 11 Newton meter square per kilogram square. So this itself is very small. Right, how much is that going to be? 0.00000000667 Newton meter square per kilogram square. So G is so small that the force becomes very small. G is so small that the force will be negligible. If you take planets are huge. Their mass is so high, then the force will be comparable. But here, it is negligible. Got it? Okay. Wonderful. Let's continue. Next, if the distance between two objects becomes thrice, what happens to the gravitational force acting between them? Yeah, a few options, but very quick. Do it. I'll give you 30 seconds. A simple numerical question, right? 30 seconds are enough. 30 seconds. Just a minute. So please solve it. The distance becomes thrice. The distance becomes thrice. What happens to the gravitational force acting between them? Yeah, everyone. 5, 4, 3, 2, 1. The time is up. Now let's solve it. Here, the distance between the two objects becomes thrice, 3 times. And what happens to the gravitational force acting between them? Now let's directly use the inverse square law. I'll directly use inverse square law. We know that force is inversely proportional to d square. First case. Second case, let's call the force as F dash. It is inversely proportional to the distance square, but the distance became thrice, so the distance is 3d, so 3d whole square, 3d whole square. This means that F dash is inversely proportional to. What is 3d whole square? 3 square is 9, d square, right? It is d square. So this is 1 and 2. Now when you divide them, you can directly divide the proportionality. Right, so when you divide them, you get F by F dash is equal to. Here you have 1 by d square for F. And here you have 1 by 9d square. 1 by 9d square. Then you can clearly see that d square gets cancelled. What is remaining here? F upon F dash is equal to 1 by 9. 9 goes to the numerator, so what happens? F by F dash is equal to 9. But what we need is F dash. Let's do the reciprocal. When you do it, it becomes F dash by F is equal to 1 by 9. So from this, what can you say? You can say that F dash is equal to F by 9. F dash is equal to what? F by 9. Now this is fine. We got the final force, let's say final force. And if I look at the options, here it is given increases by, decreases by, increases by, decreases by. And when you say increases by or decreases by, you talk about change. Okay? Increases by or decreases by. When you come across this, these refer to what? The change. What is the change? That is the question. So here change in force, if you need change in force, what is that going to be? Initially it was what? F. Finally we got F dash. I'm only taking the value. So F minus F dash. F minus F dash, we got it as what? F by 9. So F minus F by 9. You can take the LCM. You'll get it as 8F by 9. So change is 8F by 9. And is the force increasing or decreasing? The force became F by 9. So it decreases. Right? It decreases. Just a minute. So you can say that it decreases by. Decreases by is the change. And by how many times? By 8 by 9 times. 8 by 9 times the initial force. You have to be careful with decreases by, increases by. They refer to change. And hence the answer is what? Option D. Got it? So if distance increases, the force decreases. Inversely proportional. Good. Next. If the earth vanishes all of a sudden, what happens to the moon? Neglect the effect of all the other objects in the universe. So what is going to happen? If the earth vanishes all of a sudden, what happens to the moon? Everyone, very quick. I'll give you 30 seconds of time. Think. 30 seconds is more than enough. If earth vanishes, what happens to the moon? How will the moon go? How will the moon travel? How will the moon travel? Yes. So 5, 4, 3, 2, 1, the time is up. So here we are saying earth vanishes. Now understand this. What is earth actually doing to moon? What is earth actually doing to moon? Because of the gravitational force of earth. Because of gravitational force by earth. Because of gravitational force by earth, earth revolves around the sun. Because of gravitational force by earth, moon revolves around the earth. My mistake. Moon revolves around the earth. Yes or no? Now this is fine. This is what happens normally. But if earth vanishes, will there be any gravitational force on moon? And it's mentioned that neglect the effect of all the other objects in the universe. There is nothing else in the universe. Now earth is gone, there is only moon. So on the moon, will there be any gravitational force? No. So if earth vanishes, there will be no gravitational force. There will be no gravitational force. Force on what? Force on moon. There will be no gravitational force on moon. And if there is no gravitational force on moon, so what happens? So the moon will start traveling in a straight line. Start traveling in a straight line with constant speed. Why? Because if there is no force, no change in velocity. If there is no force, no change in velocity, that means if this is the moon, it will keep on going along a straight line. It will keep on going along a straight line with constant velocity. It will not be in circular motion anymore. Moon will not be revolving in a circular motion anymore. It will continue to go along a straight line. Is that clear? Good. Next. State the relation between small g and capital G. I'll again give you 30 seconds. Do it. I'll again give you 30 seconds of time. So please do it. What is the relation? I need a formula. When we say relation, a mathematical formula between small g and capital G. What will it be? There is a very simple formula that again we have to remember all the time. So what is it? So 5, 4, 3, 2, 1. The time is up. And what is the formula between them? The formula is this. Small g is equal to capital G mass of Earth upon radius of Earth square. That's it. Done. A very simple basic formula between these two. The relation between small g and capital G. And both of them are different. You have to remember this. Small g and capital G are entirely different. The value of small g is 9.8 meter per second square. The value of capital G is 6.67 into 10 power minus 11 Newton meter square per kilogram square. Got it? Good. Next question. Weight of an object is 980 Newton. What is its mass? And you have a few options. Very quick. Do it again. 30 seconds, more than enough. So please solve it. 30 seconds of time. You have to calculate the mass. So be quick, everyone. Start. The weight is given as 980 Newton. What is its mass? What is its mass? 15 seconds more. There is a simple relation, simple formula between weight and mass. If you use that formula, you'll get the answer. So 3, 2, 1, and the time is up. Okay. So let's solve it. What is the weight given as? Weight is given as 980 Newton. And we know the value of G, it is 9.8 meter per second square. And what is the formula for weight? The formula for weight is equal to mg, mass into acceleration due to gravity. So that means if I need mass, mass will be equal to weight by G. What is weight? Weight is 980 Newton. What is G? 9.8. Now you can do the calculation. Yes? Right. What is that going to be? You can just multiply with 10 on the numerator and the denominator. What is that going to be? It becomes 9800 by 98. And when you divide by 98, 98 ones are 98 hundreds are. So the answer is 100 kilograms. We are talking about mass. The SI unit is kilogram, and we have taken the quantities in SI units. Clear? Good. And hence the answer is what? Option A, 100 kilogram. Very simple. If you remember this formula, done, you'll get the answer. Okay? Good. Next. The weight of any person on the moon is about 1/6 times that on the earth. Okay. We know that weight is 1/6 times on the moon. That's fine. He can lift a mass of 15 kilogram on the earth. What will be the maximum mass which can be lifted by the same force applied by the person on the moon? Now let me explain this. Let me explain. Okay. So first of all, look at this. On earth, he can lift a weight of how much, or a mass of how much? Mass of 15 kilogram. So if mass is 15 kilogram, what will the weight be? Let's take G is equal to 10 meter per second square. So weight is equal to mg. Right, so I can call it as what? Mass is 15, G is 10. As of now, we'll take it as 150. Okay. So the weight is 115 Newton. So if the person is able to lift 115 Newton weight, 150 Newton weight object, that means he has to apply a force up. See, if I am lifting this pen, I am applying a force in the upward direction. So if the person is able to lift 15 kilograms, that means he is applying an upward force of how much? 115 Newton. So the maximum weight he can lift is 15 kilogram or 150 Newton. That means the maximum force he can apply is how much? 150 Newton. How much, whatever you can lift or how much ever you can lift depends on the force that you can apply. So maximum force that the person can apply is 150 Newton. So for maximum force is 150 Newton. Now comes the interesting part. Now if I take it on the moon, now this is the object, the force that we are applying, the maximum force that we apply will be the same 150 Newton. But what about the weight? See, if the mass is m dash, the weight is going to be how much? Weight is going to be m dash into acceleration due to gravity on moon. That is the interesting part. Okay, and if you are able to lift it, both of them should be equal, right? So let's say on moon, acceleration due to gravity on moon is 1/6 times acceleration due to gravity on earth. Right, so if both of them should be equal, weight on moon should be equal to the maximum force. Weight on moon is mass into acceleration due to gravity on moon. We have taken the mass as m dash. And the maximum force is the same 150. But again they have mentioned that Gm is equal to 1/6 Ge. So m dash into 1/6 into Ge. What is Ge? Acceleration due to gravity on earth is 10. That is equal to 150. Now all that we have to do is calculation. So m dash will be equal to 150 into 6/10. And you can clearly see 0, 0 cancels. That is 15 into 6. 15 into 6 is how much? 90. Right? So 90 kilogram. The same person can lift a mass of 90 kilogram where 90 kilogram on the moon. Because the main reason is acceleration due to gravity is different. That's it. Got it? Okay. Now, another question we have here. What is the question here? What is the time period of satellite near the Earth's surface? Neglect height of the orbit of satellite from the surface of Earth. Now let me explain this. So if this is Earth, now this satellite, let's say this is a satellite, it's very close to the Earth. Right, and we have to get its time period. For this you have to know this. The formula for centripetal force. What is the formula for centripetal force? I'll call it as Fc. It is equal to mv square by r. It is equal to mv square by r. Because if you get speed, you can get time period. Simple. Right. And here on the satellite, what is the centripetal force? On satellite, who will exert a force? Earth. So gravitational force. Centripetal force is gravitational force. Centripetal force is gravitational force. What is the gravitational force between the satellite and Earth? The same formula. Capital G, mass of Earth, into small m, mass of satellite upon Re square. Now why am I taking Re? Because see, it's mentioned that height is small. Neglect the height. So when I neglect the height, what is the distance between them? It is nothing but radius of Earth. Height is small, so neglected. So we got gravitational force, centripetal force, both of them are equal. The centripetal force is not a new force. there is gravitational force which itself will act as centripetal force. So mv square by r is equal to capital G mass of earth, mass of satellite by re square. Now you can clearly see here what happens. M cancels. 1 r and square cancels. So what will remain? V square is equal to gme upon re. So what will the speed of the satellite be? Under root of gme by re. Under root of gme by re. Is that clear? Yes? Okay, now that we got speed, we'll get the time. What is time here? For a one circle, right? For one circle, what is the distance? Distance will be equal to the circumference. What is circumference equal to? 2 pi r. 2 pi r, that is what? 2 pi, the radius is radius of earth. It is revolving around the earth, near the surface of earth, so radius is almost equal to radius of earth. And the time period will be equal to, time taken will be equal to distance by speed, so 2 pi re upon v. It is 2 pi re upon under root of gme upon re. Right, so if you solve it, you'll get the time period as, see, 2 pi into under root of re cube upon gme. I'll leave the solving part to you. Please solve it by yourself. Okay. This is the time period of a satellite near the surface of Earth. Clear? So we start from centripetal force. We say both of them are equal. They are equal. Then solve it. Get speed. Get time. That's it. Okay. So that's it, everyone. That's it for today's class. So thank you. Thanks a lot.